It looks like it's starting the broadcast. Cool. We are now live. Everyone, welcome to this week's Tea Time. We have an interesting agenda for you guys with Genetic Algorithms by John and Deep Pace URL Secrets by Paul. And we're glad that you can join us. And John is going to kick things off with Genetic Algorithms. So, John, it is all yours.
All right. I assume that you see my screen, and I'll just go for it. Let's see.
We do?
Yeah, do you hear me and see my screen?
Yes.
All right, cool. Um, so I have a few slides missing at the end because I totally ran out of time, surprise, surprise. And first I'm just going to describe some pretty easy stuff. Honestly, I think that we can all pretty much infer how certain aspects of genetics work. We're not biologists or anything. I'm terrible at that kind of thing. But the basic process of mating and passing down traits, that kind of stuff. We want to, in genetic algorithms, to really roughly emulate that and kind of copy that. It's an interesting model that originally, I guess, folks were like, well, we want this thing to evolve, and that's kind of like genetics, so let's model it totally one-to-one, just like genetics. So they followed a lot of those principles, and it turned out to be really cool results, similar to a lot of artificial intelligence algorithms. Um, it's like it kind of is self-directed in that it finds its own way, and you look at the end result, and you see this random string of bits representing a phenotype, or Bayesian whatever classifiers saying, oh, this is the best, or this is the thing, and you never know how it's derived, but computers figured it out in a cool way that hopefully I'll just really briefly describe and show my little use case. So for how we want to accomplish this in terms of an algorithmic solution would be that you want a genetic representation of the solution. Like usually you envision this as a bit string that's just a bunch of zeros and ones, and maybe if you change, like at index 2, you change the 0 to a 1, then you can test against that new phenotype or that new individual, and it should show you new insightful information and how you can further populate your group of individuals, or how that group of individuals will succeed. Secondly, you need some sort of fitness function to evaluate that solution. So if you change the 0 to a 1, we want to actually quantify, well, how is that better? How much is that better exactly? How can we measure and compare it with other individuals? In a group of 100, 1,000 individuals, that kind of thing, you'd want to pick the best for breeding so that they can pass down those positive traits, which are sometimes subjective and hard to figure out, but that's the beauty of having a large initially seeded population for your solution. So the basic process is that you get this big chunk of initial beings. So there'll be 100 or 1,000, and each one of those is your DNA. It's your bit string. It's your bunch of numbers, or whatever your solution domain demands, then that's how you start. And again, it's usually I don't know, 500 is kind of low, but maybe 1,000 or 10,000 supercomputers go a little higher, and they'll all be. Sometimes you want to seed them semi-intelligently. Like if you think that the solution looks kind of like this bit string, then maybe you'll tend to randomly focus more on that kind of thing. Personally, I just made a bunch of individuals and I mutated them a whole bunch. But we'll see that with Deep, the Python library that I use for this later. Later you have, as you're iterating through your generations, and you go down, you want to be able to select some group of those individuals in your initial seed, and you want to do stuff on them. So stuff like crossover and mutation is important and interesting, and they're kind of like the crux of how you progress to a better solution. And then termination criteria is also important. Usually it's just number of generations. But these are all things that we'll need to observe in our implementation of some sort of genetic algorithm. So if we're visualizing this as a bit string, it's kind of easy to just say, well, yeah, that fourth zero, that fourth index item should turn into a 1. And it's so often it's just a bit string But I think it's like extra helpful for some reason for me was to visualize it as a bunch of numbers or indices into another list that represent some other thing. I know you can do that just as easily with a bit string, but whatever. So this is actually how I did it for mine, which we may or may not see to varying degrees later, that what might have been 4 before in that first list of items, the fourth item is 4, we mutate it into 2, which would represent a whole different person. In your problem domain, mine was actual people, like what people are going to take care of this first thing, the second thing, the third thing. So the fourth thing is going to be handled by a different person. If they're qualified differently, then you should have better results. Crossover is different and kind of accomplishes a slightly different purpose. You want to take some of those features, and I say take distinguishing features, and usually you don't really identify those in your algorithm, but I more so mean like, you take index X and then you go to index Y and you copy them from one chromosome to the next, one DNA strand, one bit string, whatever you're going to use. So we might colloquially refer to that as mating two individuals. So if you have these two unique snowflakes, 1, 2, 4, 3, and 1, 3, 2, 4, romanticized as green and red, then using a 2-point crossover algorithm, of which there's a lot. There's a lot of ways to combine two guys, and you do kind of want to cater that to your problem domain. 2-point is really commonly used. Dare I say, in my ignorance, it's the most commonly used. I'm not really sure, but you do really have to try out different things for your problem domain. In 2-point, you want to basically take out, and I'm like kind of using my fingers here to reference, maybe you want to take out the middle, maybe you want to take out the end. So you'll start somewhere and then you'll end somewhere, and you'll just throw that in your child. So in this case, you take the whole first one to the left, and then I just took 3 and 2 from the red guy, and after I cross over that using 2-point crossover, we get the 1, 3, 2, and I colored them such that you can tell, happy green snowflake, and then it's a couple from the red guy and the green to get a nice mix that you wouldn't otherwise have gotten. Whereas mutation, maybe if you just change 1 in mutation, this will change 2, and sometimes if you're getting those positive attributes, because you only mate the higher fitness guys, then if you're taking those attributes, the higher attributes, then you'll be more likely to get better solution and to get out of any like local maxima or that kind of similar issue that we see with these non-deterministic, these types of algorithms, these class of algorithms. So here is where if I had more time, I would have shown more stuff, but I would have written more, but I ran out of time, so I'll just describe it, and then, oh no, we'll have to do a live code demo instead of having the lame text already put in. But that's fine, I have it up in the background. So my problem was, whereas we were talking kind of generically before, my problem was that I have a floor assignment on a hospital, and they have some set of rooms, and those rooms have some set of patients. Those patients have some set of needs for credentialed nurses. So like only chemo-certified nurses can push chemo into their veins. This makes sense. This is just a basic safety thing. And similarly, nurses have certain credentials. And so you have some big set of beds, like 25 to 30 beds with special needs, and you have a bunch of nurses that are scheduled at different times, and yada yada. They have different credentials. And it turns out the problem space of an exhaustive algorithm for that is ridiculously huge. And then calculating the fitness for said result is non-trivial. So infinitely huge and then non-trivial fitness equals ridiculous output times of days and weeks and stuff like that for how you schedule. So this in general is called the assignment problem, where you have some set of resources and some set of output criteria, and you need to assign them in some sort of optimal way. I would show you code, and I could conveniently because I didn't copy paste it. So I'm going to go into my project now and show you what I have for genetic algorithm, and no balking. Hopefully I'll just show you kind of what's relevant. So I have some things that aren't as important, but some things that are kind of important. So my mutation algorithm, I represented everybody as a bunch of numbers. So mutate will just pick a random number and replace that string. And these are just some kind of cool specific things with deep, DEAP, which is a Python library and pretty cool, which I wish I showed a little more on a slide, but too bad because I ran out of time. And you'll see really common stuff like this. Your toolbox is like your environment in which you're making your algorithm, and it'll do helpful things like determine how you're going to mate, how you're going to mutate, how you're going to select some folks. Using a tournament selection is how I did it, but there's a lot of different cool ways to do that. So I'll start out with population count is something like 500 usually. For me, maybe go up to like 1,000. So at this point on line 53, I will have I'll just go with 500 population. Each one representing a nurse goes into a particular room. So if I have 17 rooms and 4 nurses, then I'll have 17 rooms with beds that are taken, all that kind of thing. Then each one of this list of population will have 17 items. So it's 500 items in population, each one of size 17. And that's all random. And then down here, hopefully it reads not terribly. This is partially copy pasta. So InGen is number of generations. And we are really just going to go through and for however many generations it is, I don't know, 50 or 100, we're going to do stuff based on that. So this mating will do the 2-point crossover that I described before. And then we'll go down, and a lot of this stuff is just bookkeeping, so this stuff isn't really super important, cloning. But the mate does a 2-point crossover, and that's helpful. And then with some mutation probability, we're going to mutate them. And sorry, there's also a crossover probability. So for some amount of them, for every other group, we'll just pair each one of them. Then they'll mate, and we'll mutate, and then we calculate everybody's fitness, and we make the new population, and then we print out some helpful information on it, and then we go to the next generation. And we keep doing that over and over and over again. And then at the very end, the tool has a helpful thing to select your best individuals of the group, and that's what you'll use. So let's see, I'm sure that this just says actually do it. So I've already populated my program over here, and we see that we have 4 nurses, and they have varying skill levels. Eventually this can be a float. I think it's right now just an integer, 1, 2, 3. I've put in these different credentials, which this is kind of the more tricky thing for an exhaustive search. For all these people in all the different rooms, this adds a lot. So it's factorially complex, by the way, depending on how you set up your algorithm. Factorially complex by how I did it, it was number of beds factorial times, I think it was number of nurses factorial. And I think that you can get that down slightly, but I do think that it's still a factorial problem because you're going through permutations of things, and permutations are terrible for exhaustive searches like this. Anyways, and then I really rapidly at like 359 put in difficulties for all these guys, which means that the beds are filled. And so notice in N9 to N25, I'll get to that later. And then these 2 guys this guy needs chemo, this guy needs wound vac. So CJ is both chemo and wound vac. So I could say chemo, comma, wound vac, and then CJ would have to get that. I've done that in the past, and it worked fine. I mentioned about the beds in N9 through N25. So these are the bed names, and I know it's not very clear, but I use another program that outputs GraphML, and this is just test data for me. So for convenience, I just left them as N, and N means node for them. So if I were to visualize this using, I think this is PyMatlib or MATLAB plotlib, or I don't know, something about MATLAB and something about some lab and plotting some stuff. this is a representation via graph of the floor and how the rooms look. So these central nodes are the hallways. If you want to get super ninja, then you'd probably add a few more nodes, because not everybody walks in perfect straight lines and takes 90-degree turns. But anyways, these are weighted edges corresponding to the distance from node to node. And eventually you'd probably get out your floor map and make a very awesome one that I just didn't care about for testing. But I do use a graphing library. Which one do I use? NetworkX to import this, GraphML. And it's just a happy ecosystem of some open source products that I found worked well together. Anyways, who cares about that? That's the rooms. If I were to execute this, then I should be seeing some output. So I just clicked go. Now what we see here is these first generations. I have some negative fitness scores. So that means that I do not have a working solution yet. And they're all kind of humorously, this is looking like it's probably not going to converge on a working solution. But we can see that a lot of these stats are changing. So whereas the first batch, the first generation of all completely random folks, we got a minimum score of 1,089, which is really bad. But as time goes on, which means that, I mean, that's not even possible given my algorithm, so I think I must have input something stupidly. Anyways, that represents that there are something like 10 of the rooms have things that can't possibly be accounted for. And so I lower the fitness score by about 99 for each one of those. And then I weigh in geography of the floor so the nurses walk less, and that kind of stuff. So let's see. Oh, you know what? I have 17. Is that right? I'm counting up my nurses for, yeah, so I don't have enough. I don't think I have enough. Yeah, I couldn't possibly, because I maximized my patients to 4. And so you'd have, so the previous algorithm, why it was stuck at -94, sorry, I made an impossible restriction that you can only have 4, for each nurse can only have maximum 4 patients, and you can't do that with 17 beds and 4 nurses, duh. So one guy wasn't even being cared for, so -99. That's where that came from. So now this is looking a lot more legit, where these numbers going higher and higher means that the floor geography is slightly better, so the nurses will walk ever so slightly less. And after a while, it kind of converges, and like all these solutions are all the same, pretty much. So we'll see that my results are, you know, these people get such and such. So we'll just compare really fast. Chemo and 11. Who has chemo can either be Jan or CJ. So CJ, let's see, Jan. So Jan has N11. She's chemo certified. That makes sense. WoundVac, N13, only CJ, so CJ has to have N13. CJ does indeed have N13. So we see that this does yield correct answers. It's hopefully it'll, over time, you know, if you bump up the population, then you yield closer and closer to optimal answers. And it's all around helpful to not exhaustively search, like, I don't know, trillions and quadrillions of problems, and instead you very quickly converge to a working answer. I do have exhaustive, by the way, and I had to put in a hard stop at 4,444, and so notice that this is 6.21, the score is 6.21. So if I start on this one, I actually haven't used this in forever, I just had sudden inspiration, which never works out well, but we'll see what that comes out. Yeah, so an exhaustive search, for example, after 4,000 iterations, which is nowhere near what the genetic algorithm did, admittedly, but it comes up with almost -300, and that's because it's literally trying every single possible way to have all these patients split out, and so the program is severely punished because Narissa only has 2 patients, whereas these other folks have 5, and it should be a lot more equaled out. So she should maybe have, yeah, and then I'm counting it out. Yeah, okay, that works. So she should have, I mean, at least 3. So I punish it on that fact as well. And then it's probably minus 99 for that, and then minus 99 because these beds aren't cooked up right. So it takes crazy much longer to do this exhaustive than the genetic. And I've been really happy with the deep library. I'd suggest that if you guys have a problem like this, that you check it out because it's really cool. You know, depending on what you're trying to accomplish, really, I think that it solves the problem really well. Oh, and I forgot that you can print out the room assignments, so I have a little cool Excel spreadsheet, but that's not at all related to the talk, so off topic. Does anybody have any questions? Say that first while I muse about my dumb Excel spreadsheet thing.
Yeah, I've got one for you, John.
Yes?
You say working on problems like this. What I was wondering when you were doing this is what sort of where does this go? Where do you see this leading in the real world for your development work as far as applications?
Yeah, so my wife is a nurse, and she works at a hospital where they just got a new layout because they built a new hospital, and they have I probably should have led with this. The initial problem really was that it takes the charge nurse of a given floor, of which there are many floors in this new hospital. It takes the charge nurse something like 4 to 6 hours a day to do out these room assignments. And they have a lot more complicated room assignments, like, anyways, the beds have a few more criteria, and they incorporate a few more things, like if the nurse before them had these rooms, they only want to hand off one time, so the nurse after can just take over from one previous nurse. It's easier, you know, in practice. But they had this problem where they were spending crazy amounts of time. Again, 4, 5, 6 hours a day for each floor, of which there are like, I don't know, 10, 12, more than that floors at this particular hospital. And I was just mortally offended. And so I made this thing, and we've talked about licensing it to them and then probably other folks. Evidently, I wasn't there for this, but my wife told her coworker who does the assignments that I was making this, and apparently the coworker cried. So, fun anecdotal evidence that hopefully this has some sort of commercial value, and I can incorporate hopefully more criteria that they use in the real world, which I simplify and hand wave a lot of the time.
No, that's cool. Now I know this example wasn't just totally made up, so that's great.
Yeah. It's slightly less contrived. How about that?
Well, that's...
Yeah. Any other questions? Alrighty.
Okay. Well, thanks, John, so much for that. That was interesting. I'm going to check the chat room to see if there's anything. We have a few people watching, about 6 people. So you may post your questions in tea time when you get this. We'll give them a minute because it's like a 30-second to minute lag before it hits YouTube. But in the meantime, yeah, that was mind-blowing. John, thanks for doing that.
Sure.
And we have one from Aaron. Did you post a Fox presentation the other day? It was about genetic programming and music.
I don't know what you're talking about. There was, what was that? Could that have been in the other IRC? Yeah, I don't know. I don't think I posted that though. I don't know what you're talking about. That it sounds vaguely familiar, but I don't know.
Cool.
Yeah, I think it was in the other IRC. But it was a YouTube talk about a genetic algorithm to calculate musical counterpoint.
That's right. It was.
I watched it in double time. It was pretty cool.
Yeah, that was sweet. I did not post that. Maybe I can try to find that in the meantime and post it in our in the Tea Time channel.
Yeah, it's in my history. I'll post it in there.
Cool. Answer questions by selecting one from the list. Oh, that's pretty cool. This is the first time I used the question and answers app. I see Michael Burns's icon here, and it says, "Can you embiggen the presentation?" And then I can select it, and I see a +1 beside it. So what do you do from this point? Do you select it? Oh, you could delete it or select. Okay, I'll select it. See what happens.
Is a +1 like a vote?
Yeah, probably so. So I've just selected there's probably some type of moderation going on there. I could delete it or select the question. Do you guys see it in your pane to the right?
Yeah, if I switch to questions, it says you're currently answering that.
Oh, cool. Yep, currently answering. Nice.
Yeah, after the presentation, if you're watching on Plus, you'll be able to see the list of questions and click on it, and it'll jump the presentation to this point, since you selected that you were talking about it.
Awesome. All right, I almost want another question to come through. Yeah, I totally agree. So you won't have to synchronize the questions. So yeah, we'll go. Paul, are you ready at this point? I think we got all the questions from John. John, great work on that. Are you feel like you're at a point to where you could present your work, Paul? And if you're speaking, you're muted. We can't hear you.
Okay. Yeah, no, I definitely am ready. I started getting a lot of stutter, and I thought it was on the sending end, but no, I think it's on my end. So anyway, I think my screen is now successfully being shared. I'm coming through. Somebody say, yeah, you hear me and see me.
I hear and see DPaste URL secrets.
Excellent.
Yeah.
All right. Cool. So this was a funny little one I wanted to do, partly because, as some of you know, I created and operate dpaste.com, and people I work with use it, which is great. It's a kick, and sometimes I just want to sort of tell people things that might sort of make it slicker for them to use. As I worked out the talk, it turned more into something about a specific aspect of the implementation that I think is interesting and has some influence on use, but is mostly a sort of something you wouldn't have known just from looking at it. So I will get to it here. So yeah, my accidental first slide. Spoiler alert, here's the entire urls.py file for dpaste.com. So now you know every secret there is to tell. But the part of the URLs that I want to talk about mostly is the PKs, is the IDs that are the individual pastes, unique identifiers. Back in the day, when I first created this pastebin, which was 9 years ago at this point, it was very simple, generic Django app setup, which was the model had an automatically, pardon me, had an automatic increment integer ID field, and that was the PK. So literally the first 6 pastes were numbered 1, 2, 3, 4, 5, 6. Those were actually the source code to the entire app. Those were my first paste. There was 3 Python and 3 HTML template files, and then the PKs went up from there. They got to about 1.7 million over the course of the many years the thing was up, and I've been thinking about a lot of changes I wanted to make, and I've talked before about what I call the dpaste 2.0 upgrade, and I did a little blog post on it, and talks about a bunch of the stuff that I changed. But one of the things that I took on there was to change the way that the PKs happened. It just so happened that at the time I made this shift, every live paste happened to be a 7-digit integer, just because of the way the incrementing had gone. My new PKs also ended up being 7 digits, and that was arrived at in a way I'll tell you about. But that was sort of a happy thing because it meant the old keys were perfectly valid when I did the migration, because I was changing servers and syncing the content as I developed, and so I could do a switchover without losing user data or having a service interruption, which was a tricky part of the whole thing. But anyway, the new URLs are not auto-incrementing IDs, and they're not decimal integers either. I use base32 for them, and I took Douglas Crockford's base32 idea. He has a whole write-up on it, and you can easily find it. But basically, you take 10 digits, 22 letters, and the letters you leave out, it's kind of funny. I, L, and O you leave out because they can be confused with digits. So the and then U he leaves out for accidental obscenity. You had to leave out one more letter, and you got to have a reason. So that's the reason is that you can't. You'll have fewer misspelled phonetic dirty words if you don't have a U in your digit set. So why not follow that precedent? So I use the same digit set. I like base32 because it was compact but not noisy. I didn't want to do a sort of base 64 looking thing. I didn't want to do upper and lowercase either. This is just me being fussy about appearance. And so one of the secrets, such as it is that the case doesn't matter. If you type in a dpaste URL with all lowercase, it'll redirect you to the uppercase version, and there you are. It doesn't care. It's not case sensitive. It prefers, it has its canonical preferred form, but that's uppercase on output, but it doesn't require that for input. So that's one thing. And when I was rereading Crockford's spiel on his base32, one thing I caught that I didn't do, because basically, for all I know, I'm the only person who ever types in dpaste URLs instead of just copying and pasting and clicking on them. One thing he specifies is that an I or an L should be converted to a 1 on input, and an O should be converted to a 0, which I think would be a sweet thing. So anyway, if you see a dpaste URL on a billboard and you're trying to type it in, and you don't know whether something's a 1 or an I or an L, it's a 1. If you don't know whether something's an O or a 0, it's a 0. So the ambiguity always resolves to the digit. So that's a little sort of semi-usable tip related to the URLs. The other thing I wanted to talk about was how the things are generated. I said they're not incrementing keys. I thought a lot about how to do this, and would I use some kind of UUID generation? I do a SHA-1 of something, and I've thought of all kinds of different ways to generate unique, quote-unquote, random strings in order to have keys without the set being so small that it didn't cover all the ground of of full database, and not being so overblown that it was a gigantic URL that just had 10 times as many characters as it needed to, because that's part of the point of pastebin URLs, is if they're shorter than whatever they're reproducing. So after doing some research, I came across this cool thing called MurmurHash, which is a very good hash function or family of hash functions. It's not cryptographically secure, but I don't care if people can reverse them. What I cared about is that it had great properties as far as collision goes, which is important to me. I don't want to have two different pastes collide in the key space, and it also had a 32-bit output, which was in the space that I wanted for how much precision I wanted in the key. So I found a Python implementation of MurmurHash and went for it. So the way that the primary key generation works is something like this. This is only mildly elided from what's real in production. This is in my model file for the paste items. I have a number-based conversion library called BaseWhat, and so you create a BaseWhat object with the digits of your base, and base 32 digits in my settings is the Crockford set that I just showed you. And then I take 4 text fields. I take the content, then I take the poster's name if there's any, I take the syntax, and I take the title of the post, and those together, I join them together, and I do that little encoding thing because MurmurHash barfs on some Unicode stuff that it shouldn't, but so I sort of sanitize it for that. But anyway, basically concatenate the content, the poster, the syntax, and the title, and hash them with MurmurHash, and I make it positive. It returns signed 32-bit integers, but I want only positive ones. So I concatenate, I hash, I add 2 to the 31st, and then I turn it into a base 32 integer, and that's it. That's how I generate the PKs. So I like this because it was what I did when I was trying to decide how long to make the keys was I took the existing corpus of paste, so there were, I don't know, 10 or 20,000 items, and I ran them all through my various attempts at the algorithm and looked for collisions. And with 5 digits, I had 1 or 2 collisions out of the whole corpus. And then I sort of added some more stuff and tried to stress test it a little bit. And I ended up at 6 was okay, and 7 was my margin of safety. So I'm fairly confident that, given the behavior of the hash algorithm and the size of the corpus and the possible future bigger size of the corpus, that 7 digits is going to have effectively no collisions. And the collisions are not catastrophic in this case, but I would very much like to not have any, so I did my best to try to make it a good compromise between length and safety against collisions. So I discovered one funny thing about this, so a benefit. Let me show you the logs. This is, I know this tiny, minuscule print. It's hard to read, but this is a tail of the log from today, in fact, of my debug log on the live server. And you can't necessarily read much of this, but one thing you'll notice if you just scan it is there's clearly some lines that look kind of the same, right? They're about the same length and have the same, even if you couldn't read the characters. And in fact, there's one that seems to keep coming up, and the PK is 2K6ADBS. And it comes up over and over, and it's not just from one IP. So what this is a very common thing, is a Django site that's live, that's in debug mode, and people or spam bots hit the page that's throwing the error, and if they're people, they find the share this traceback button and they hit it and they post a dpaste. Or if they're spam bots, they just post on whatever, they hit whatever button is in the page and they post a dpaste. So by one or both ways, I get a lot of post to dpaste from debug pages of Django sites that are live in debug mode. But the cool thing is that if somebody just hits that button on that page, the 4 things that I use to determine the key don't change. The title, the poster, the syntax, and the content are all preset in that form that's being submitted. So unless they edit the form contents, which are preset in that page, they are submitting the exact same thing, which means it hashes to the same value, which means my database does not fill up. So just to do a little quick check on this, I found that PK there from that page that was showing up again and again, and I did the math, and the anti-spam side effect is here. I did a head and a tail on the log just to show you what the date range is. So we're basically talking about a week's worth of stuff, and you can see the first one and the last one are from different IPs, and that's typical throughout. There are some dupes from some IPs, but many different IPs hitting that same page and submitting to dpaste. And the count was almost 4,000 over that week, so that's a lot. And that's just one of many that are out basically being vectors for robots hitting the paste button. Those 4,000 items are just 4,000 overwrites of one thing, because via the hashing algorithm it knows that it's the same thing, so it doesn't need to generate a new one. So that was a happy side effect of my choice of method to generate the PKs. One thing that made me think it's a 2K6 ADBS. So let me see if that one's still in there. Oops, pardon me, wrong window. Are you? Oh, come on. Sorry, I'm trying to get to something, but instead I jumped to that. Yeah. Okay, let me try this again. Don't click in the slide because then you'll advance the slide. Interesting. Okay. All I was trying to do is add a tab to my slide window, but Google Slides doesn't want to do that for me. So I'll skip it. The secret there was if you add .txt to any dpaste URL, you get the raw text version. There are other ways to get there, but that's the URL hacking ways. If you do .txt at the end of the primary key of the ID, it sends you the raw text version. So that's just a handy, quick way to Control L .txt return, and you've got the plain version that you can select. So then the last item I wanted to share about the dpaste URLs is this one, which is when Adrian Holovade and Jacob Kaplan-Moss retired from being benevolent dictators for life from Django, Adrian made this nice long post, and in it he said this thing. I don't know how many other people noticed this. He said, please, no more Django Pony, it's stupid. Well, Mr. Grumpy Pants. I saw that, and it's funny because many years ago, I was hanging out in the Django IRC channel, and by many years, I mean like this is probably 2008, who knows. And I said, I bet I can add a pony to the Django, to the dpaste site in 5 minutes, because Django's so awesome and fast, and I did it. This was before Django ponies were a thing, but anyway, I threw a pony in there, and it was at dpaste.com/pony. But the last edict of the benevolent dictators for life was no more Django pony, so it's gone. Cute pony removed. No more ponies for you. And in fact, if you go to Django, if you go to dpaste.com/pony, it redirects you to that very post from Adrian. So that's sort of his karma for banning ponies, is that any crawlers or anybody else who hits that old pony URL will end up at his essay banning them. All right, that's it. Any questions? Any secrets you wanted to know that you didn't find out, or anything I explained without sufficient clarity, or anything else? I'm watching the chat, so if you got something to type, that's cool too.
Hey, Paul, I remember the pony thing also well. Well, I guess about 3 years ago, we had like this DevOps, TechOps culture, and we had like little this hat, this pony hat that we would put on is pink, and I think maybe Chris Lizo and Mark Chase kind of started this, but I'm pretty sure you remember all of this.
Yeah.
And then that culture kind of faded away.
Yeah.
And the last desk that pony was on was my desk, and then Chris Heisel left and Mara Chase and everybody. I eventually took that pony home, and it was just around the house doing nothing, and people kept asking me what it is, and I really didn't have a good answer for them. But if I were to go home and look for that pony now, I probably wouldn't find it. I have no idea what happened to it.
I'm pretty sure I saw a picture on Twitter of Mora hugging that pony or something. So I think I know exactly the one you mean. But yeah, I was it was my only trend-setting moment was I was way ahead of that for some reason. Yeah. Any other comments or questions? No, all right, I will give the mic and screen back. Thank you, everybody.
Yeah, cool. You know what? I wonder though about that pony thing. So Jacob, he gave a lot of the tutorials, and he was very ambitious. 3 years ago, when he was talking to us, we hired him to do like 3 days or so of training to get us up to speed on Django. He was like, "Oh, I wrote this book, this Django book," and I was like, "How was it?" And he was like, "Oh, don't ever do it. It's too much work." I was like, "Okay," but I wonder like. I mean, so what is he doing now? So he's not really. the dictator of Django anymore? Like, did he just quit it altogether? You have any idea? Or anybody?
He's at RevSys as far as I know. I haven't seen him in probably a couple of years at this point, but as far as I know, he's still doing that kind of consulting that he did for us, just not running the Django project itself.
So, and let me share this. I'm going to post this in the chat because it's funny. And thanks for sharing that. So if you look in the chat, there's a URL with a picture of guess what? How recent is this one? Anybody know? All right, cool. Well, you guys can definitely check out that picture. Any more questions or anything?
I just checked the headers on that JPEG, and it says 2009 for what it's worth. So we know it's at least that old.
Wow. Yeah, I can see that because Mara definitely looks a little different now. Okay, well, thanks to our speakers, John and Paul. Those were great presentations. I'm gonna definitely play around with the DPaste tricks you taught me. I definitely needed that .text extension one because I'm always sharing, and I'm looking for like the best way to share data. And then John, your complex algorithms really blew my mind. I know that the nursing industry beyond your wife will find something like that very useful. And of course you'll become rich, so just think about us in the future, because it sounds like you're going to save a lot of people a lot of time. Okay, well, what was that, John?
Thanks. Yeah, hopefully they love it. They better.
They better. Yeah, let us know how that works out. And it's Friday. I want to wish you guys a good weekend, and to take care. Thanks for everything.
Thanks, everybody. Bye.
All right.